Hello, this is another demo this time though it's about edgier physics. Now, physics is a really good idea in theory, but in practice it can be a little bit weird. The simulation is currently paused because it only works when I press the space button. A really weird thing that seems to happen though with all physics engines is the following. You see how the structure almost breathes and shockwaves bounce back and forth through it, but very slowly. Right, but the cool thing about it is its extreme ability to be able to do something without interference from anything else. So stuff you could never do in the real world, like build this tower here which is completely formula controlled. Now in the real world this would probably cave in or fall somehow. I don't really want to talk about how, just mainly because of a useless builder and human things, but this is positioned perfectly, at least in theory. Now first of all, let's just drop this sphere in. The sphere has been sort of pushed in from the start, that's why it's faster than the gravity. Now, as it goes through, what we didn't see at the bottom here is that objects are almost going... here you can with those two blocks there. Objects are actually going into each other, embedded, if you will. That's called the skin width. That is what has caused the simulation, if it has a lot of weight on it, to sort of contract and expand, almost like it's breathing. Now, if we continue to drop this, you can see at the bottom as well, you get like a crumple zone form. Now I can't really explain why, because this would imply that they were sort of pointing inwards to start with at a certain angle, but as you know that isn't the case. And also you'd think that if any force was to carry on because they're touching, it would try and rip them out, not push them in. Unless of course they were ripped in and that angle tried to push them in from the sides. It's very confusing, especially late at night. Right, now after a while the physics simulation will calm down. And you can see another problem with simulations that starts to arise. Get a look at it from the top, replay this on a bit more. Now you can see here it's almost formed like an X shape on the X and Z axes because Y is going up. Now what I used to position these was, was trigonometry, so I could almost get them in a circular pattern at 10 steps per 360 degrees. Now I think that's what that's caused, because every 90 degrees you're going to get a quarter of a phase in trigonometry terms. So with sine it's going to go from 0, 1, 0, minus 1 back up to 0 in 360 degrees phase. So what this shows is that the problem arises with trigonometry, the parts where decimal points come into play. So because your computer can't handle a certain amount of, an infinite amount of decimal points, the simulation will never be as accurate as realistic would be, as the real world would be even. So as a result, where the number is more definite, i.e. has less decimal points than your computer can handle, meaning it's accurate, you can see where it's very how it should be, if you will, which is why you get those spikes forming, because they're definitely there. Now what's interesting about that is that tells us that the simulation has been biased, because in theory, because of the way I position them, they should be equally around all angles, but this shows random distortion. Another weird thing, because my finger is still down on the space button, is the sphere itself. Now if you look on this side here, you can see that there is in fact a gap, which is hard to explain. Sorry, it really is late and I'm tired, and it's not uniformly spread, which is weird, especially on that left direction, not compared to the other 4 points, 3 points even. Right, that pretty much concludes this. This is like basic to a geophysics, and I'll probably bring up one which has probably a load more boxes to knock down later tonight, if I'm still awake. Now if we just look quickly in wireframe, not sorry about the objects, probably because it's an alpha channel by the look of it, you can see that the objects themselves have been able to land oddly. Like that one there for example, it's landed on its side, perfectly on its side, which is why it hasn't toppled over. You can see even if I'm holding down the space button, which is pretty much real time, it still hasn't toppled over, suggesting that the objects themselves are biased, because there is no way in the real world that could land perfectly like that. Now over time the principles of mathematics that we've talked about, the limitations of them, might actually kick into that object and it will topple, which is what tends to be the problem with accurate physics simulations, where everything is accurate and not realistic at all. So that kind of concludes this really, and the limitations of, well, real-time physics. Maybe even like not real-time batch physics, but you know, that's got controllable accuracy because you could use string mathematics for that. That's another thing though. Thank you.